In this question, we've been told that the proportion of people in a large population who wear glasses is P, so it's an unknown proportion at the moment. A random sample of 4 people is taken from the population. The random variable x represents the number of people in the sample who will wear glasses. We're asked to show that the probability that x is greater than 2 is going to equal this expression. So firstly, we need to recognize this is a binomial distribution. We had 4 attempts, so 4 trials, and we had a constant probability of success, which was P. The random variable number of people who wear glasses is going to be discrete, and we can make it 2 possible outcomes. Either they wear glasses or they don't. So the binomial distribution I will define where n is 4 and p is unknown. The probability that x is greater than 2. Firstly, I'm going to want to rewrite that to use a value that I am including. So the probability that x is greater than or equal to 3. Well, if I only had 4 attempts, there's only 2 possibilities here. Either x equals 3 or x equals 4. And we'll be adding those together. Since we have an unknown value for p, we can't use our calculator here. We're going to need to default to the original probability function. So we know that the probability that the random variable equals any particular outcome is going to equal ncx, p to the power of x, and then q to the power of n minus x. So in the case of the probability that x equals 3, it's going to be 4c3, p to the power of 3, and then q to the power of 1. And then the probability that x equals 4, 4c4, p to the power of 4, q to the power of 0. Now this last term is an edge case. It's the maximum number of successes. So 4c4 we recognize equals 1, and q to the 0 we recognize equals 1. So we can simplify from here. 4c3 we should recognize as 4. So that's 4p cubed q plus p to the power of 4. I'm going to factorize here. Take out a common factor of p cubed. That leaves us with 4q plus p. Just looking towards what I'm meant to be showing, I seem to be quite close to what I'm looking for. I've got the right term on the outside of the brackets, but inside the brackets, I've got p's and q's, and the term I'm looking for does not have any q's. We know that q is actually 1 minus p. It's the complement of p. So I'm going to rewrite this in terms of p. So I've eliminated q from the expression. Just expanding within the bracket to tidy up, we get 4 minus 4p plus p. And we're almost there. Simplifying the bracket once more, 4 minus 3p. And this is exactly what we were asked to show. Okay, so in a few simple steps, we were able to generate an expression for a probability range. We didn't have a value of p, which meant we could not use the calculator, but reverting to our original probability function got us the expression we needed.